Hey there, space cadets and particle pals. Today, we're diving into the wild world of antimatter. Buckle up, because things are about to get weird. Imagine a universe where everything is backwards, where up is down, left is right, and your evil twin is actually the good guy. That's basically what antimatter is, the bizarro world version of regular matter. But I'm not talking about some sci-fi parallel universe here. Antimatter is real, and it's right here in our own cosmos. So, what exactly is this mysterious mirror matter? Well, it's just like normal matter, but with a twist. Every particle has an evil twin. I mean, an antiparticle. These antiparticles have the same mass as their normal counterparts, but their electric charge and other properties are flipped. For example, the electron's evil twin is called the positron. It has the same mass, but a positive charge instead of negative. And the proton's nemesis? You guessed it, the antiproton with a negative charge. Now, you might be thinking, cool story, bro, but why should I care? Well, antimatter isn't just some theoretical concept cooked up by bored physicists. It's a fundamental part of our universe, and it's full of surprises. For starters, antimatter was created alongside regular matter in the Big Bang, that cosmic explosion that kicked off our universe billions of years ago. It should have produced equal amounts of matter and antimatter. But here's the kicker. We live in a universe made almost entirely of matter. So, what happened to all the antimatter? That, my friends, is one of the biggest mysteries in physics. It's like showing up to a party where half the guests have vanished, and nobody knows where they went or why they left. Scientists have been scratching their heads over this antimatter asymmetry for decades. But recently, they've made some mind-blowing discoveries that are bringing us closer to answers. Let's start with a recent experiment at CERN, the particle physics wonderland in Switzerland. Researchers there have been playing with antihydrogen atoms. That's right, they've created the antimatter version of the simplest element, and they've been subjecting these anti-atoms to all sorts of tests. One big question was, how does antimatter respond to gravity? Does it fall down like normal matter, or does it float up like some kind of anti-balloon? Well, hold on to your hats, because the results are in. Drum roll, please. Antimatter falls down. I know, it doesn't sound very exciting, but this is actually a huge deal in the world of physics. It confirms a prediction made by none other than Albert Einstein himself. In his theory of general relativity, Einstein said that gravity should affect all matter the same way, regardless of its internal structure or composition. And now, almost a century later, we've finally proven him right for antimatter too. But wait, there's more. The CERN team didn't just drop antimatter and call it a day. They've been subjecting these antihydrogen atoms to all sorts of wacky experiments. One of the coolest involves cooling antimatter down to ridiculously low temperatures. We're talking just a fraction of a degree above absolute zero. That's colder than outer space, folks. And when they did this, something bizarre happened. The antihydrogen atoms started behaving in ways that defied expectation. They maintained a surprising uniformity, even when jostled around in liquid helium. It's like they were doing some kind of quantum dance, all in perfect sync. This discovery could open up new ways to study and manipulate antimatter. And who knows, it might even lead to practical applications down the road. Antimatter-powered spaceships, anyone? Now let's talk about another mind-bending experiment. This one involves creating hybrid atoms made of both matter and antimatter. Yeah, you heard that right. Scientists have managed to Frankenstein together atoms with antimatter components. They fired antiprotons into liquid helium, creating antiprotonic helium atoms. These Frankenstein atoms are like the ultimate odd couple. A regular helium nucleus paired up with an antiproton. It's like a buddy comedy where one character is from our universe and the other is from Bizarro World. And here's where it gets really weird. When the researchers cooled these hybrid atoms down, they started behaving in ways that broke all the rules. Normal atoms in a dense fluid would go haywire, their properties all over the place. But these matter-antimatter hybrids, they stayed cool as cucumbers. acting in perfect unison. It's like they were doing a synchronized swimming routine in a pool of liquid helium. This discovery was so unexpected that the scientists spent years double-checking their result. They thought they must have made a mistake. But no, it turns out antimatter just likes to keep us on our toes. Now, you might be wondering, if antimatter is so cool, why don't we see more of it? Well, there's a catch. When matter and antimatter meet, they annihilate each other in a burst of energy. It's like the ultimate cosmic breakup. They can't even be in the same room without exploding. This makes antimatter incredibly rare in our universe, and makes studying it a real challenge for scientists. But that hasn't stopped them from trying. In fact, antimatter research has led to some pretty amazing real-world applications. Ever heard of PET scan? That stands for positron emission tomography. It's a medical imaging technique that uses antimatter to create detailed pictures of the body. So the next time you or a loved one needs a PET scan, you can thank antimatter research. And who knows what other discoveries are waiting to be made. The study of antimatter could unlock secrets about the nature of our universe. It might help us understand why matter won out over antimatter in the early cosmos. And it could even lead to new forms of energy or propulsion systems. Imagine antimatter-powered starships exploring the galaxy. It sounds like science fiction, but with the pace of antimatter research, who knows? It might just become science fact someday. So there you have it, folks. Antimatter, the mirror image of our universe. It's weird, it's wild, and it's full of surprises. From falling antihydrogen to Frankenstein atoms doing quantum dances. Antimatter keeps proving that truth is stranger than fiction. And the best part? We're only scratching the surface of what this bizarre stuff can do. So, the next time someone tells you that physics is boring, just hit them with some antimatter facts. Trust me, their minds will be blown faster than you can say positron. Until next time, keep looking at the universe with wonder. And remember, for every particle of matter out there, there's an antiparticle waiting to shake things up. Stay curious, space cadets.